It all began with a faint little ripple that showed up on a graph. It was such a tiny fluctuation, it could have easily been dismissed as nothing more than background noise from the equipment. But that tiny deviation kept appearing over and over again until it eventually settled into a consistent and stable pattern. And that's when it transformed into a mystery, one that demanded an answer. The nucleus of an atom, where every single particle is supposed to follow well-studied and established physical laws. Yet suddenly, something unknown, a mysterious force, seemed to appear out of nowhere. This force was so powerful it shattered the model of particle behavior that scientists had relied on and tested countless times in the atomic world. The particles began behaving as if they were under the influence of another force of nature, something like a fifth fundamental interaction. A force strong enough to shake the rules, yet somehow completely hidden until now. For a long time, scientists kept wondering if what they were seeing was just a margin of error, maybe just noise, or even a glitch in the detectors themselves. But the data refused to go away. It just kept coming again and again. And finally, in a formal research report, a name appeared: the Atomkey anomaly. Hello everyone! These strange phenomena were first observed at the Atomkey Institute for Nuclear Research, located in Hungary. It happened in 2016 during an experiment that was investigating the decay of beryllium-8. Right there in the lab, the team recorded something for the very first time. An event so baffling that only an unknown force, a possible fifth force of nature, could explain it. Welcome to our channel. As always, let's break it down step by step and take a closer look. The four fundamental forces that govern the universe. Why did the discovery made at the Atomkey Institute shake the world of physics so deeply? To truly understand that, we need to look back at the four fundamental forces that form the foundation of everything in the universe. Gravity. It's the force that pulls galaxies together, gives birth to stars, and keeps us standing firmly on the ground. Gravity dominates when we look at the universe on a grand cosmic scale. But when we zoom into the microscopic world, its influence all but disappears. Inside an atom, gravity is so weak it's essentially ignored in calculations and experiments. The electromagnetic interaction. It's the master architect behind the visible world we see around us. This force keeps electrons orbiting around atomic nuclei, creates lightning and light, and powers chemical reactions as well as all our modern technology. But on a large scale, the positive and negative charges in molecules cancel each other out, and this force loses its ability to control things on a cosmic level. The strong interaction. It's the fierce guardian that holds the atomic nucleus together. This force is unimaginably stronger than gravity and acts like a kind of cement that binds quarks and nucleons into one solid unit. However, its range is so short, it can't even reach across the width of a single proton. Just a tiny step beyond that, and it vanishes, like a magic spell that ends at midnight. The weak interaction. A quiet but crucial force that drives important transformations in the universe. It's responsible for particle decay, for turning neutrons into protons, and for igniting the fire that fuels the stars. Still, this force only operates under very specific conditions, and it's confined to an incredibly tiny scale. These four forces have governed the universe from the very beginning up until today. From massive galaxies and enormous black holes, all the way down to the very last atom that makes up your body, these four forces stand like pillars holding up the reality we live in. But now, a problem has emerged. Not one of these forces can explain the strange phenomenon that was observed in Hungary. Signs of a new force. In 2016, at the Atomkey Institute for Nuclear Research in Hungary, physicists were studying the decay of a short-lived atomic nucleus known as beryllium-8. It was considered a routine process in nuclear physics, with nothing mysterious or out of the ordinary about it. During this decay, electrons and positrons are produced, and the way they fly apart is supposed to follow well-established and thoroughly tested physical laws. But to everyone's surprise, the detectors picked up an unexpected surplus of particles flying away from each other at around 140 degrees. This kind of emission couldn't be explained by the strong interaction, the weak interaction, or even the electromagnetic force. It was as if, in the very moment of decay, an extra interaction, an entirely new force, had suddenly emerged between the particles and shifted their momentum. In modern physics, there's a clear and simple rule. Each fundamental force has a corresponding particle that mediates it. Photons carry the electromagnetic force, gluons handle the strong interaction, and the W and Z bosons mediate the weak interaction. And when it comes to gravity, quantum theory suggests that the graviton would be the particle responsible for transmitting that force. In reality, though, no one has ever directly observed a graviton. That's why, if a new kind of interaction truly exists, there must also be a brand new particle acting as its carrier. At first, scientists around the world responded to the discovery with great caution. Every physicist knows the truth. Most anomalies don't rewrite the textbooks. They usually turn out to be mistakes. So the experiment was repeated again and again. But the anomaly refused to disappear. Science never takes words at face value. Even if there's a place in the universe where miracles are allowed, it certainly isn't in the world of physics. Just because a single odd-looking curve shows up on a graph doesn't mean a scientific revolution has occurred. To boldly declare to the world that a brand new force of nature exists, you need independent, solid proof to back it up. That's why, as soon as Atomki's experimental results were made public, research centers around the world began chasing the mysterious particle believed to mediate this unknown force, a particle that came to be called X-17. In the United States, China, and Japan, scientists launched their own experiments, each using different methods, trying to recreate the effect that had been observed in Hungary. But the results were far from consistent. Some experiments showed faint hints of the anomaly, while others failed to detect anything unusual at all. Still, the persistence of the scientific community started to pay off. In 2019, the same team at Atomki once again picked up signs of the anomaly, this time during the decay of an excited helium-4 nucleus. That new result gave further support to the hypothesis that the X-17 particle might actually exist. In Europe, the search was taken to the next level with none other than CERN joining the effort. The research teams from LHCb and Atlas carried out a series of ultra-precise measurements, looking for even the tiniest imbalance in how particles scatter. But so far, not even the world's most advanced detectors, whether at CERN or anywhere else, have been able to catch that elusive particle in a way that would settle the matter once and for all. The data remains conflicted. Some researchers believe they've found subtle signs, while others insist there's absolutely nothing there. And still, the mystery remains unsolved. That's exactly why the world's largest particle accelerator facilities are now gearing up for a brand new round of experiments. Is there really a fifth force of nature out there? Before long, we just might get a clear and definitive answer to that question. The fifth force and the dark sector of the universe. By the end of the 20th century, physicists had already come to a profound realization. What we observe as reality is really just the surface, a kind of cosmic display window. All the familiar things we know, stars, planets, people, atoms, make up only about 5% of the entire universe. The remaining 95% consists of dark energy and dark matter. We can't see them, but they are the forces that hold sway over the fate of the cosmos. They will decide whether the universe keeps expanding until it reaches absolute zero, or if it will eventually collapse back into a single point. Or perhaps space itself will be torn apart. That's because our universe isn't just expanding, it's expanding faster and faster, accelerating as it grows, at least as far as we can currently tell. And yet, we still don't know what these mysterious components, this 95% of the universe, actually are. Physicists have long suspected that in this dark sector, there could be hidden physical laws at work, completely separate from the ones we know. Laws powered by their own particles and their own forces, ones that barely interact with our visible world. The key word here is barely. There must be some kind of interaction, even if it's incredibly faint. And that's exactly why X-17 has become so important. If this particle truly exists, it could act as a bridge linking the dark sector to the world of visible matter. Like a doorway connecting two realms that share the same universe but barely even acknowledge each other's presence. This kind of connecting particle is known as a dark boson. A particle that can understand the language of both ordinary matter and the hidden world beyond. Do you see just how enormous this could be? If X-17 turns out to be nothing more than a mistake, scientists will simply close the chapter on a strange report and move on. But if it's real, then for the very first time, we'll be brushing up against the deeper structure of the universe. We'll be reaching out to secrets that have been hidden from us ever since the very first moment of the Big Bang. And that's when the biggest question of all comes to the surface. If a fifth force truly exists, what exactly could it lead to? The invisible power of the fifth force. Scientists always begin with the most conservative assumptions. Maybe this is just some new particle, nothing more, they say. But time and time again, the history of science has shown that behind a single tiny particle, an entire powerful interaction can be hiding. Take the neutrino, for example. At first, this particle was proposed simply to plug a gap in energy calculations during nuclear decay. But later, it turned out that neutrinos stream endlessly across the cosmos, carrying energy from stars, and even play a role in the evolution of the entire universe. So what if history is about to repeat itself? While physicists carefully examine the data, another possibility is beginning to emerge, that X17 might be just the tip of the iceberg. It could be the faintest trace of a force far more powerful than anything we've imagined. A force that doesn't just transfer momentum, but has the power to alter the very structure of matter itself. A universal force that acts equally on the atomic scale and across the vastness of space, completely ignoring the familiar limits of scale we've always accepted. Until now, we've believed that the atomic nucleus, bound tightly by the strong interaction, was the most indestructible structure in the known world. But if X17 truly exists, and if we can rewrite the interactions inside the nucleus, then maybe the strong force isn't the only thing holding matter together at all. Maybe there's an even deeper structural layer, with a more fundamental kind of connection we've never seen before. To put it simply, this would be like opening a hidden hatch beneath the floor, one we never knew was there. Matter at the edge of its limits. On Earth, diamonds are the ultimate symbol of hardness. Nothing compares to them. And in the cosmos, that role belongs to neutron stars, which represent the pinnacle of physical strength and density. Inside a neutron star, atoms no longer exist as recognizable structures. Electrons are crushed and forced to merge with protons, forming vast oceans made entirely of densely packed neutrons. This kind of matter is so compact, just a single cubic centimeter of it weighs as much as an entire mountain. But even matter this unimaginably dense has a breaking point, a limit beyond which it cannot withstand the pull. That limit is set by the strong nuclear force. However, if there truly exists a force powerful enough to rewrite the rules that govern how quarks behave, then no atom, no star could be considered absolutely stable anymore. So far, in human laboratories, this force has only shown hints of itself on the tiniest of scales. But what if, somewhere out in the vastness of space, this force is acting at full strength? In that case, the matter we're familiar with could shift into a completely different state of existence. Quarks might start binding together under new rules, forming bizarre and unfamiliar kinds of matter. Matter could transform into quark-gluon plasma, a form that existed just after the Big Bang, or even into some brand new reality we haven't yet discovered, let alone found the words to describe. If the fifth force is real, it might have the power to break matter down into its original code, then rebuild it from scratch using a completely different set of rules. When you think about it that way, it's not so hard to imagine that the physical laws we know are just one narrow slice of a far deeper, more mysterious universe. In other words, if the fifth force truly exists, it could affect not only atomic nuclei, but even the destinies of entire stars. The strange behaviors of galaxies, the puzzle of dark matter, the unexplained reactions inside stellar cores, any one of those might be traces left behind by this mysterious new force. Which means the laws of physics as we understand them today could merely be the outermost skin of reality. Beneath that surface lies a world where both matter and space behave in completely different ways. Right now, experiments are underway all over the world to settle this debate once and for all. If X17 turns out to be a mistake, then physics will continue down the path it's already on. But if it's real, then we're standing on the edge of discovering a fifth fundamental force, and an entirely new vision of the universe. Yes, sometimes a single, tiny little particle is all it takes to change everything. If you enjoyed today's video, give it a like and share it with your friends. Thanks so much for watching. We'll see you next time. Take care.